Hi, B period. It's Mrs. Buckley. I wish I could be with you today, but I made a video lesson for you to follow along with today. Hopefully, it feels like I'm right there with you, teaching you this, and we will be able to hit the ground running on Thursday when I'm back. So, what we're going to do is continue looking at exponential expressions. You did some of these for homework after the test. So we're going to just do a little review of that assignment first, and then see if we can generalize some of the rules for simplifying exponential expressions. At the end, we're going to look at two kind of funky cases. What happens when I have an exponent of 0? Or what happens if I have a negative exponent? And then after that, you're going to work independently on a Desmos assignment. Okay? All right, let's get started. So I'm looking at this first expression, x to the 7th times x to the 4th. And I know that x to the 7th just means x multiplied 7 times. So I'm going to expand that part out, maybe let's make that in red. So I'm going to have x 2, 3, 4, 5, 6, 7. I'm going to make that smaller because I'm going to have to get 4 more in there. And then I've got an x to the 4th. Okay, well, x to the 4th, I know that's x multiplied 4 times. 1, 2, 3, 4. So what I've done is I've expanded the whole expression, x to the 7th times x to the 4th, and I'm going to see how I can write it in as a form that's as simple as possible. Well, how many x's am I multiplying together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I can write my final simplified expression as x to the 11th. Let's look at the next one. This one I'm going to actually write, I'm going to expand it in 2 steps. So the first thing I'm going to say is, well, I know I have an x to the 4th inside this parentheses, and the exponent outside the parentheses means I'm going to multiply what's inside the parentheses 3 times. So I'm going to first write it as x to the 4th times x to the 4th times x to the 4th. Then if I wanted, I could expand it even more, because inside each of these parentheses, that x to the 4th means I'm multiplying x 4 times. So I can write it as x times x times x times x, x times x times x times x, x times x times x times x. Well, how many x's am I multiplying together here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my final simplified form would be x to the 12th. Okay, next one. I have m to the 14th over m squared. Okay, oh man, this is going to be a lot of m's to write out, but I'm going to go ahead and do it. M to the 14th in the numerator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that's all over m times m. Well, I know that m over m is a 1. Okay, this is a smart, what I call a smart one or a giant one. Okay, and I know that those two are essentially going to cancel. Same here. These two m's being a giant 1, they're going to cancel. So I'm going to be left with how many m's in the numerator? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 m's. Okay, I'm going to give you a couple minutes to see if you can expand and simplify the next 3 on your own. Ready, set, go. Okay, so hopefully you had a moment to try these different problems. And we're going to take a look at them one by one here. So D, I probably expanded it more than you did. And I did that for a reason because I want you to understand what's going on here. So what I did for D, I said I know I'm going to take x squared times y to the fifth and multiply it 4 times. So that's what you can see here. 1, 2, 3, 4. Then I said, well, let me put all the x's together and all the y's together. So we put all the x's. Here are all my x's. I know I have 4x squareds. And here are all my y's. I have 5y to the fifths. Then I said, if I want, I could have expanded that even more. And because I know each of these x squareds is x times x. So if I wanted, I could have said, well, x squared times x squared times x squared times x squared. Really, that's 8x's all multiplied out. And y to the fifth times y to the fifth times y to the fifth. That's really, here's y to the fifth times y to the fifth times y to the fifth times y to the fifth. So I have, that makes y to the 20th. Okay, so my final answer is x to the 8th, y to the 20th. There. You might not have shown all those steps, and that's okay. I did that because I really want you to see what's going on here. For E, I expanded it, and then I saw that I'm going to have these giant ones that cancel each other out. X over x, x over x. Here I have that the 3 y's in the denominator cancel with 3 of the y's in the numerator. So what I'm left with is x to the third in the denominator and y to the 8th in the numerator. Okay, my last one, F, I expanded it. Here, make sure that if you have a 2 over 8, these big numbers out in front, I'm simplifying that just like I would any fraction. So I'm thinking 2 over 8, I know that's equal to 1 over 4. So it's like here I have a 1 times x to the 10th over 4. Okay, I have x to the 10th because the 2 x's in my denominator cancel with 2 of the x's in the numerator, and I'm left with 10 in the numerator. So it's like I have that 1 times x to the 10th over 4, but I know if I have just a 1 in front, I don't need to write it. Okay, good job with that. Now, this got pretty tedious. We had to write out a lot of x's here. That wasn't so fun. It would be really nice if we could generalize what's going on here into some patterns. That way, we don't have to expand it every time. We can use the pattern or the rule to simplify these in the future. So we're going to do that next. Okay, I've got x to the 25 times x to the 40. What if I had that? Well, I'm not going to write out 25x's and 40x's. That would be crazy. But I can imagine in my head what would happen if I did that. If I had 25x's and then 40x's, how many x's would I have altogether? Well, I would have 65 x's multiplied together. What did we do? We added the exponents. So here for the generalization, I know x to the m times x to the n is going to be equal to x to the m plus n. X to the m plus n. Okay, why is that true? How could we explain that? Well, maybe m and n represent how many x's are being multiplied. So when I'm multiplying them together, I can just add how many x's are being multiplied. Okay, I don't have enough room here. I'm just going to write that. So total is m plus n. Okay, the next one, x to the 36 over x to the 13th. I'm not going to write out 36 x's on top and 13 on the bottom. But I'm thinking what happened up here in these previous examples. Well, I know that when I had x's in the numerator and the denominator, some of those canceled out. For this example, I can imagine what would happen. The 13 x's in the denominator would cancel with 13 of the x's in the numerator, and I'd be left with how many? Well, I need to subtract to find out. Well, 36 minus 13, that's 23. So this would be x to the 23. So what are we doing with m and n here? I subtracted. I said that's going to be the same as m minus n. So I can see multiplying two together is like adding the exponents. Dividing two powers is like subtracting the exponents. Okay, why is this true? Well, it's true because n of the powers in the numerator will cancel out because we know we are making smart ones. Okay, let's look at C. What pattern do we know there? Oh man, that would be hard to write out 12x to the fifths. Well, what happened here when I had x to the fourth to the third? Remember that we had my three groups of 4, okay, which we could write as x times x times x times x times x 3 times. That sounds like multiplication. Here, x to the 5th to the 12th, that would become x to the 60th. There would be 60 x's, 12 groups of 5. So what am I doing here with my exponents? When I raise a power to another power, I'm multiplying those exponents together. Okay, so n represents how many groups? Well, when I have how many groups, I know I need to multiply. Okay, you ready? Now things are going to get even more interesting. Number 3, describe everything you know about x to the m over x to the m. What is its value? How can you rewrite it using a single exponent? What new conclusions can you draw? Okay, let's talk about this. Instead of using x to the m over x to the m, I'm going to plug in a number for m because I think it makes it a little more concrete. So what if I had x to the fourth over x to the fourth? Well, I know that's the same thing over the same thing. I know all 4 of those x's in the numerator are going to cancel with all 4 of the x's in the denominator. That's going to be 1. But wait a minute, we also just learned a rule about what happens when I'm dividing one power by another. Okay, this rule up here. We already just looked at that rule. So it seems to me like I could also rewrite this as x to the fourth over x to the fourth. I could rewrite it as x to the 4 minus 4. Well, what's 4 minus 4? 4 minus 4 is x to the 0. Okay, 4 minus 4 is 0. So this would become x to the 0. What does this mean, people? If I have x to the fourth over x to the fourth is equal to 1, and x to the fourth over x to the fourth is equal to x to the 0. Well, what it means are these are the same thing. Okay, I know now, because we're talking about it, x to the 0 equals 1. And in fact, anything, okay, imagine I have anything raised to the 0 power equals 1. Okay, anything raised to the 0th power is 1. Pretty cool. We're going to be seeing that some more this year. Okay, let's go on to the next one. So we just talked about this, that x to the 0 is 1. Okay, now we're going to use division to explore the meaning of x to the negative 1 and x to the negative 2. Okay, what does it mean to have a negative exponent? Well, let's look at what happens here. Okay, I've got x to the fourth over x to the fifth. I know using my canceling, my expanding and canceling, like we did up above, that this is going to be that the 4 in the numerator, the 4 x's in the numerator are going to cancel with 4 of the x's in the denominator, and I'm going to be left with 1 over x. Okay? But we also just learned that rule about what happens when I divide powers. So I know that x to the 4th over x to the 5th is also equal to x to the 4 minus 5, which is the same as x to the negative 1. So we have that x to the negative 1 is the same as 1 over x. Okay? X to the negative 1 is the same as 1 over x. Let's look at the next one. Again, I could expand it and simplify it, and I would be left with 1 over x squared. Or I could use my pattern and know that I can subtract the exponents when I'm dividing powers, and that would give me x to the negative 2. So here we see that x to the negative 2 is the same as 1 over x squared. Okay, last one. We'll do the last one here together, and then we'll see if we can come up with some conclusions. I have x, I'm not going to write all these out, 7 x's in the numerator, 10 x's in the denominator. I know that everything's going to cancel except for 3 x's left in the denominator. So this is going to be 1 over x to the third. Okay, 1 over x to the third. But I could have also used my new little rule and done x to the 7 minus 10 and gotten x to the negative third. So we have that x to the negative third is 1 over x to the third. So what does this mean? What does this mean? That these three things are true. Well, notice what's happening here. Now I haven't written, for this one, we haven't written a little 1 here in the numerator, but 1 over x, that's the same as 1 over x to the 1. Okay? So what happens with the negative exponents? Well, it looks like if I have a negative exponent in the numerator, it's going to send it down to the denominator. Okay, notice I have x to the negative 1. It comes down here to the denominator and becomes x to the positive 1. Okay, same here. I have x to the negative 2 in my numerator. It gets sent down to the denominator and becomes x to the positive 2. Here I've got x to the negative 3 in my numerator, and it gets sent down to my denominator and becomes x to the negative 3. Okay, so sometimes I like to think about the negative exponent as an elevator ticket. Okay, I like to think about it like an elevator ticket. If you have a negative exponent in the numerator, that little guy gives the ticket to the elevator man, who sends him down to the denominator, where he no longer has an elevator ticket, so he becomes positive. Similarly, if there is a negative exponent in the denominator, he gives that ticket to his negative ticket to the elevator man. He gets sent up to the numerator, where he becomes positive. Okay, we're going to be practicing this here. And for me, when I'm doing these problems, I always think the best thing to do is to get rid of the negative exponent first, then simplify the rest of the way using these patterns that we found up here. Okay, those are my steps. Other teachers or tutors or helpers might teach you other things, but I can guarantee you that this is your best bet for getting these problems right. So we're going to practice these together. I'm going to do one, and then I'm going to pause, give you a chance to try one. I'm going to do one, pause, give you a chance to try one. Okay, using those steps. So first, for letter A here, I'm first going to write it only with positive exponents. I'm going to get rid of any negative exponents. Well, I have 3 times k to the negative 5. I'm going to zoom in on this here. What does that negative 5 apply to? A lot of people mess this up. They think that the negative the negative 5 applies to the 3 and the negative 5. But that is not true. It only applies to the k, not to the 3. Hold on one second. I'm going to plug in my computer. So I'm just going to take a second to rewrite this so you guys see what I mean. I have 3 times k to the negative 5. This negative 5 only applies to the k. It does not apply to the 3. So when I go to rewrite it as a with only positive exponents, the only thing that gets sent down to the denominator is the k to the 5th. Okay, the 3 stays in the numerator. And then the k gets sent down to the denominator and becomes a positive 5. It uses up its elevator ticket. It is no longer negative. I want you to try letter B right now. Okay, hopefully you tried letter B. Again, this is 2 times m to the negative 9. That negative 9 exponent only applies to the m. It does not apply to the 2. If it were to apply to the 2, it would have to be in parentheses, like this, that quantity 2m to the negative 9. But because it's not in parentheses, that exponent only applies to the m. Okay, so what happens? I think of that as like a little elevator ticket. The m to the 9 that's in my numerator, it gets sent down to the denominator. Okay, I kind of am drawing this over 1 to show you guys that there's nothing in the denominator right now. If you first wrote it like 1 times m to the 9th, that's fine. We want to start getting in the habit of knowing that we don't have to write those imaginary ones. Okay, now I have this other column here, simplify further if needed. These two don't need to be simplified further. Let's take a look at the next one. I have x squared times x to the 5th. The first thing I'm going to do is rewrite it only with positive exponents. Well, I have an x to the negative 2. That's going to get sent down to my denominator and become x squared. Then I have an x to the 5th. That's not negative, it's positive. So it's going to stay in my numerator. And I have x to the 5th over x squared. Okay, then it says simplify further if needed. Now, when we say simplify further if needed, we want my final answers to have only positive exponents. Okay, so we've gotten rid of negative exponents. We're not going to go back and have a final answer with negative exponents. I only want positive exponents. Here I'm thinking, okay, I have 5 x's in my numerator and 2 in my denominator. I know that the two of the x's in the numerator are going to cancel with 2 of the x's in the denominator. Okay, I'm going to be left with x to the 3rd as my final answer. You go ahead and try the next one, y to the 3rd times y to the 8th. Okay, hopefully you got a chance to try that one. My first step is to send any negative exponents down to the denominator. So here I'm going to have y to the 3rd over y to the 8th. Then I'm going to simplify it further. I say, okay, well, here I have a y to the 3rd in the numerator. I know that 3 of those y's are going to cancel with the 3 y's in the numerator. And I'm going to be left with y to the 5th in the denominator. What's left in the numerator, though? it would be incorrect here to say that your answer is y to the fifth. I have to remember that I have an imaginary placeholder 1 here in the numerator. So here I'm going to have a 1 over y to the fifth. Okay, the y to the fifth has to be in the denominator. Next one. Notice now I've got two negative exponents. Well, they both have elevator tickets. The y to the negative third in the denominator, he's going to come up to the numerator. The y to the negative 2 in the numerator, he's going to come down to the denominator. And then they're both going to become positive. So this is going to become y to the positive 3 over y to the positive 2. They switch places. Can I simplify that further? I sure can, because I know 2 of the y's in the numerator are going to cancel with 2 of the y's in the denominator. And I'm going to be left with a plain old y. You try the next one. Okay, hopefully you had a turn to try D. I have a negative exponent in my numerator. It's going to be sent down to the denominator. Okay, I'm going to have m to the 7th. That's not going anywhere because it's positive. Times m to the positive 6th over my placeholder 1. Can I simplify that further? I sure can. I have 7m's times 6m's. That's going to give me m to the 13 in the denominator. Okay, last one. Give that a try. Actually, I lied. We've got some more. It's not your last one, but try it. Okay, now you have a negative exponent in your denominator. That's going to get sent up to the numerator. So we have x to the third times x to the 6th. If you want to put it over 1, you can, but you don't have to. Can we simplify that further? We can. I have 3x's multiplied to 6x's. That's going to give me x to the 9. Okay, last 4 examples. These all involve some parentheses. Okay, so we're going to be talking kind of about order here, order of operations. However, that's still, I want you to think about first, before you do anything else, getting rid of the negative exponents. It's going to make your life easier. So here, how do I get rid of the negative exponent here? Well, that negative 2 exponent applies just to that x right there. It's inside the parentheses. So I'm going to rewrite it as 1 over x to the 2nd to the 3rd. Okay, 1 over x to the 2nd to the 3rd power. Well, what does that mean? This means I'm multiplying 3 of these together. So it's going to be 1 over x squared times 1 over x squared times 1 over x squared. Well, that's going to be 1 over x to the 6th. How many x's do I have in the denominator? I have 6 of them. Okay. Next one, give it a try. All right, friends, let's see how we did on this one. Now remember, this is 2 times x to the negative 7th to the 3rd. So this negative 7 only applies to the x. It does not apply to the 2. So when I rewrite it inside the parentheses with no negatives, I'm going to write it as 2 over x to the 7th to the third. Well, that's going to be the same as 2 over x to the 7 times 2 over x to the 7 times 2 over x to the 7. Okay, what happens in my numerator? 2 times 2 is 4, times another 2 is 8. What happens in my denominator? I have 3 groups of x to the 7. That's going to be x to the 21. Okay, imagine 7 x's and another 7 and another 7. There's going to be 21 of them total. Okay? The last two, I have a negative exponent on the outside of my parentheses. That means that that negative exponent applies to everything on the inside. So what I'm going to do is think of it as this whole thing over 1. So everything in the numerator gets sent to the denominator. It's going to become 1 over, in parentheses, xy to the 6th squared. Okay, again, I just like to get rid of the negative exponents first. Feel like it's the easiest thing to do. Then I know, based on my nice little pattern that we talked about up here, okay, my nice pattern up here, I know that what I can do is think of this as 2 groups of x to the 1 and 2 groups of y to the 6th. So what is that going to become? Well, it's going to become x squared, because 2 groups of x to the 1 is 2 x's, and then y to the 12th, because 2 groups of y to the 6th will be 12 y's. Okay? I hope this is making sense to everyone. Last one, letter I want you to try right now. All right, friends, for this one, again, the -1 applies to everything inside that parentheses. So I'm going to send everything down to the denominator. Okay, I could think of this raised to a +1, but that's just the same as not having a parentheses there at all. So my final answer is 1 over a squared b. Okay, that's all I have for you in terms of notes. These challenge problems are optional. If you'd like to try them, I will go over them with you next class. But I do want you right now to take a second to write yourself a little explanation of 0 exponents and negative exponents. Okay? Go back, look at what we did to write what a 0 exponent means. Look back at how we explained what a negative exponent means. Write yourself multiple ways of thinking about those things. Okay, once you have a solid explanation, what you're going to do is post a picture of your work, numbers 1 through 6 and 7 optional, to Schoology under this classwork assignment. And then you'll see on the Schoology, whoops, let me stop sharing my screen actually. Then on the Schoology link, you're going to see a place for you to do the Desmos assignment, which is a card sort matching activity. If you finish that in class, if you finish the card sort, awesome, and you get it all right, you can click the check answer button and check that you're right. Once you get it right, you can start your homework and potentially have time to finish that in class today. All right, friends, I miss you all, and I will see you on Thursday. Thank you.